So let's actually work on the second design problem. So you work on this. I give you a few minutes. You actually see, are you able to design a combination circuit with 3 inputs that the output is the square of the input, okay? So that means you want to do this. You want to actually make a circuit like this. So you know how many inputs you need. You need, actually it's mentioned, you need just 3 inputs, right? So you need to know, okay, you need 3 inputs. I call that X, Y, Z, but it didn't mention what should be the number of the output. It just says, okay, you need 3 inputs and the inputs should be, the output should be the square of the input. That's it. So you need to actually a little think about this. So whenever you have 3 inputs, you tell me what's the biggest number you could make with 3 inputs? What's the biggest number you could make with 3 inputs or 3 bits? What's the smaller input I could give here? What is the actually the biggest number I could actually have here as an input? What is the smallest number you could give here? So what is the smallest number? So definitely 0, right? So what is the smallest input I could have here? It is a 0, right? So that means whenever I give 0, square of the 0 should be 0 in the output. So the next one is, what is the biggest number I could have here as an input? Just type in the text box. So see, what is the biggest number? 7, definitely right. So the biggest case is whenever you have 3 inputs, right? So 3 input is 7, that's right. So if I give 3 input here, 3, 1, so that means 1, 1 is the biggest. I couldn't make more than 7 with 3 bits, right? So the biggest number I could make with 3 bits is 3, 1, which is 7. So you tell me, if this is a 7, what should be the output based off this design that you want to do? Should be square. What is the square of the 7? 49, that's right. You keep hearing in your mind, okay, the biggest number I will have on the output is 49, right? So how many bits I need to represent 49? This is the key question here. How many bits do you need to represent the 49? So you start with the 1 bit. If you have 1 bit, what is the biggest number you could represent with 1 bit? Type on the text box. The biggest number that we could make with 1 bit. 1, definitely right. What is the biggest number you could make with 2 bit? 3, that's right. So what's the biggest number you could make with 3 bits? 7, that's right. What is the biggest number you could make with 4 bit? Is actually 15, that's right. So that means if I say you the output should be 4 bits, the answer is that's wrong, because with the 4 bit you couldn't actually represent 49, right? So you could actually say, okay, 1, 2, 4, 8. So based off that, you guess how many bits do we need for 49? You tell me. You want to able to represent 49. How many bits do you need based off these explanations? How many bits we need? That means the output should be how many bits? Yeah, let's check the 6. So if you have 1, 2, 3, 4 bits, definitely is not enough. The biggest number is 15. So if you have 1 more, it should be 16. So what is the biggest number I could make with 5? So it should be 16 plus 8. You have 24 plus actually 4, 28 plus 2, 30 and 31. Definitely is not enough. 5 bit is not enough. So then I need to go 1 more. So that means if I have 1 more, which is 6 bit, I have 32. So definitely 32 plus 16, I have 48 plus 1, 49. So definitely is fine. the 6-bit definitely is enough for actually represent 49. So that means this is step 1 and 2, that you are figure out what should be the number of the output. So the answer is number output should be 6. This should start to F5, you could call that F4, and you end up with F0, okay, 0 to 5, which is the 6. So this is actually very important, the steps to understand, okay, based off these design, your output should be actually 5-bit, because this you just only able to represent 49 with the 6-bit, not with 5-bit. With 5-bit, the biggest one is 31, okay? So that means you need actually 6. So you actually label them F0 to F5, okay? And the input, we already mentioned, the input should be 3. How I get these 49? I say, okay, the biggest number I could have as input is 7. 7 squared should be 49, so at least I need the 6 bits in the output. So any actually question about number of the inputs, which is somehow input is already you have on the question, it should be 3. Any actually problem with why we should have 6 bits in the output? Is it clear? Okay, so that's actually the first step that here we mentioned. We actually need to know step 1, know how many inputs, how many output do you need. Step 2, put the label for them. So I actually give the label XYZ for the input and F0 to 5 for the output. So the rest should be easy, okay? So see, I'm actually back here. So you need step number 3, truth table. So you actually put the truth table here. So you say, okay, I have actually 3 inputs similar with the others, X, Y, Z. So how many different bit pattern I could make to power 3, which is 8. So 0, 0, 0, 0. So 1, 1, 1, 1. So you just make this like this. So okay, so that's not good. So to get rid of this. Okay, so yeah. So back to, okay, so these. Okay, just extend this because you have 5 actually the output, right? So you need actually have all of them as output. Okay, so now next, so you have 0, 0, 1, 1, 0, 0, 1, 1. So here you just have 0, 1, 0, 1, 0, 1, 0, 1. Okay, so I actually give a label to the output, which we have here. We start from this F0, F1, F2, F3, F4, and F5. Okay, so I just separate each of these. So okay, yeah, probably use the other color. So start with the, so this is actually the next step, right? I make a truth table. I have input in one side. I already know how many different bit pattern I could make in the input, right? And then you need to complete the other side, which is the right side, based on the inputs that you have on the left side. So it starts with the 0. I want to design a circuit. Whatever I have in the input, the square of that should be on the output. So it starts with the 0. What is the square of the 0? So square of the 0 is 0, definitely. So you actually have 0, 0, 0, 0, 0, 0 here. Just in case I write this is 1, this is 2, this is 4, this bit is 8, this is 16, and this is 32. Okay, so the next is 1. So what is the square of 1? Square of 1 is 1. So see how I'm writing 1? This bit is the smallest bit, so should be actually 1. So the all others should be 0. Okay. What is the next? What is the square of 2? Square of 2. Type it. Square of 2 is 4. Yeah, definitely. So the F2 is 4. So I have 4. Then the others should be 0. Okay. So go to the next. What is the next? This is 3, right? 3 square is 9, right? So 3 square is 9. So see, you need actually 1 8, which is F3, and 1 F0, which is 1. So this is 9. So that means this should be output whenever this is 3. So then you have 4. 4 should be 16, right? So this should be 16. The F4 is 6, and it should be 1. The all others should be 0. Okay. So what else we have here? So we have 1. This is 1, 2, 4. This is 5. What is the square of 5? Square of 5 is 25, right? So 25. See how I make 25? So this is 16. This is 8. So that I have 24 plus 1. I have actually the 25. The others should be 0. So what is the next? Is 6. What is the square of the 6? Square of 6? Yeah, the square of 6 should be 36, definitely. You actually put 1 here, which is the 32. Right now I need 4. So where is 4? 4 is F2. So I add here. So that means 4 plus 32. So that's actually 36. Okay. So what else we have? 7. This is actually, we actually review this whenever we want to figure out about the number of the output. So 7. 7 squared should be 49. You tell me how I could make 49. 49. If I have 32 plus 16, right? So 32 plus 16, it should be 48, right? 48. I need 49. So I just add 1 here, which is F0. So it should be 49. Okay. So this is your truth table. So actually, this is the most important part, right? So then you say, okay, so see here you have 6 output. So that means you have 6 function, right? For each function, you need to write them based off the standard form, then actually make that, then simplify them. So there is some of them which you don't need to do anything. So see, I start with 0. So let I take a look to the F0. So you need to do the same thing for all of them because you have actually 6 output. You need to make 6 function and have 6 K map for each of them. So start with the F0. You tell me. Again, I just write in the form of the sigma midterm. You tell me the number of the midterm. So what is the first midterm we have for F0? First one. So this is F0. Just take a look where that is 1. So definitely on the midterm 1. That's right. Where is the next is 3. That's right. So where is the next is here, which is 5. So where is the next is 7, that's right. So 1, 3, 7. So this is your function for f0. So it is the function with 3 variables, x, y, z. Its k-map should be 8, actually. Should has the 8 square. You put x here, y, z here. Just the numbers should be 0, 0, 0, 1, 1, 1, 1, 0. It should be just 0, 1. So if you do that, it should be 0, 1, 3, 2. It should be 4, 5, 7, 6. Okay, 4, 5, 7, 6. Then you use the other color, so it should be actually. So to see what we have here, so you have 1, which is definitely is this. This is 1, right? So you have 1. So you have 1 here. So you have 3. So this is 3. You have 5 is 5, and you have 7. So 1, 3, 5, 7. So you tell me how many sets we have here. How many sets with how many members? Yeah, definitely 1 with 4. That definitely is right. So see, you just select this as just 1. So x is 0, 1, nothing there, and y is 0, 1 is nothing, and z is 1 and 1. So the f0 is just z. Okay, that means you connect directly your input z to the output. It actually give you a f0. So this is for f0. Take a look. I'm not going to do all of them because they are similar. Okay, you could do that as a practice. So let I write 2 more. You take care of the rest. Okay. So how about the f1? So do I need to do anything for f1? So if you take a look to the f1, so you could say f1 equal is no midterm or sigma max term, all these max terms. So what it means, it tells f1 is all the time is 0, right? So it's never changed to 1. So that means the f1 is 0. It should be its function, right? Why? Because the f1 is all the time is 0. It's not related to the input, right? It's not related to the x, y, z. Whatever they have all the time, f1 is 0. So just I write f1 is equal to 0, okay? So let I do one for you. You could do the same thing for all of them. You need to simplify for f2, for f3, because these are just one. Same thing for f4. So, and F5. Let's do for F4. So you take care of F2, F3. I'm just write that for F4, okay? So let's do for F4. So again, for getting the F4, you say sigma midterm. So which midterm we have for F4? Which midterm? What is the first number? The first one is here, right? Which is the 4. Yeah, that's right. So you have 4. What's the next is here is 5. That's right. And what's else you have? You have 7. So you have the same table. So I put that here. So this is X, this is Y, Z. I'm not going to write the number, just use whatever we have here, okay? So 4, where is 4? 4 is here. So you have 1 here. So then where is 5, 7? Yeah, 5, 7 is here. So you have 1 here, 1 here. This is 0, 1. This is 0, 0, 0, 1, 1, 1, 1, 0. So that means F4 should be this. So you tell me what we have for how many sets we should have here. For F4, do we have the sets with 4 members? The answer is no. So it looks, it should be one with these two, and another one should be these two. Okay, so the x is 1 for these, y is 0, 0, z is 0, 1 should be gone. So x prime y plus, actually, what else we have here? So for this, you actually have x again is 1, you write 1, and the z is, y is 0, 1 here, it's gone, and the z is 1, 1, you have x's, okay? So you do the same thing. I did for f0, f1, and f4. So you, as a practice, you do for f2, 3, and 5, okay? So whenever all of them is done, you just implement this function by actually with just whatever you got end up as a simplest form, right? So see, for example, you do the same thing. You put x like this, you put actually one not here, give you the x prime. So here you just make y. So just put the not in the other side. You have y prime, give one input for the z, put the not, and have another one here, okay? So for example, you want to make the f0, so if I just change the color, I start with the f0. So see, f0, you don't need anything for f0. You just need one wire because f0 is z, right? There is no gates. So I connect this to the z and say, okay, this is f0, okay? So for F1, technically you don't need anything. You just have one ground on the one part and just connect this to the ground. So it should be your F1, right? So this should be F1. Just connect it to the ground. That's it. Yeah, maybe, I don't know, maybe we could do this actually the other way. So maybe this. Let's make our circuits more organized. Okay, do this. Okay, this is F1, which is just connected. This is F0, just Z. So whatever you got actually for F2, F3, and F4 and 5, you need to implement here. So I just get F4, you do the rest as a practice. So F4 is x prime y plus xz. So that means for I just put 3 dot here, which means you do the others. So for F4, I need definitely one OR gate. So for these OR that you see here, then I need actually 2 AND, right? So this is the first AND, it's connected to this. This is actually second AND, which is connected here. Whatever I have here is F4. And take a look to the input. The first one should be x, y prime. Okay, I just connect this. So I have x and y prime. So this is y prime. So this is for first one. And for next one, I have x and z. So this should be connect here and it should be connect here. Okay. So if you do the same thing for the others, so that means you end up with one circuit. And if you implement that circuit on the real board, so again, you just need how many inputs? You need 3 switch for your inputs and you need 6 LEDs, right, on your real breadboard, okay? So whenever you give any numbers, so 0, 0, 1, it's actually give the square. So for example, if this is 1, so the LED F0 should be on, the all should be 0. So that means actually this is 1. Same thing for the others, right? So this is actually how you could design the combination circuit. So it could be actually any circuit. This is just 2 examples that we had. So, but if it works for any other design that you need for your specific application.